All right. So in lesson 7.2, we're still talking about our exponential functions that we learned yesterday. If you recall in lesson 6.8, we reviewed graphing functions with transformations. Remember, if you have y equals a times the function x minus h plus k, all the transformations that occurred. Better or worse on lights? Okay. Oh, I thought my computer's plugged in. Recall that your a would multiply the y coordinate by the factor of a. H means you add the opposite of h to the x coordinate. K means we add k to the y coordinate. So we worked on these. We put them on the test that you guys took on Tuesday, especially that second half where you had to do the graphing. Well, today we want to apply the same transformations, but to exponential functions. Let me give you one from last week. Suppose I gave you y equals the square root of 4x minus 12 plus 1. So if you recall from last week, what do we got to factor off of the x here? Correct. We can take out the square root of 4, of course, is 2. So if you recall last week, our transformations, remember we probably put this in a two-step transformation. What's going to happen to the y's? And the x's? But remember, we had to have points to do this too. So since we're looking at a square root graph, we knew that on square roots we always did 0, 0, 1, 1, 4, 2, and 9, 3. So who can tell me where 0, 0 would now be? 3, 1 is correct.
What?
Where'd I lose you at, Miss Lane?
See, I thought you were going to subtract the 1 and then square root.
Please?
I thought you were going to subtract the 1 and then square root of sign. How'd you get the 2y plus?
To find the inverse, I would. But we're not finding the inverse, we're just graphing. How we got the 2y plus 1, see the 2 sitting outside the square root now? That tells us to multiply the y coordinates by 2, and the plus 1 means we add the 1 to the y coordinates. And then the minus 3, that's how we got the fact that we're going to add 3 to the x's. Since it's a square root graph, we always do these points. Okay? We're going to do more of these today, so hopefully it'll start gelling a little bit. Okay? All right, so who did me 3? Was that you? Desiree did 3, 1. Haley, can you do 1, 1? Yes?
2.
Getting closer. 2 times 1 plus 1.
3.
You got it. Let's keep moving across the room. I see Seth Cap. What about 4, 2? Travis, do you mind? Not 3. X plus 3. Try again. 4 plus 3. Okay. 2 times y plus 1. Perfect. 9, 3. Christina Cowan. Yep.
7.
Great. 12 and 7. Am I getting your memories jogged from doing this last week? Okay. Today, we want to do the same thing, but with the exponential functions f of x equals b to the x. Remember what we learned yesterday. All exponential graphs will pass through the following points. Tell me one of the points that they'll pass through. Tell it to me, Drew Weissman. 0, 1, yes. Tell me another point, Georgia Hummel. Okay. Drew said 0, 1. Okay. Josh Timmers.
1, 1.
Not 1, 1. 1b, correct. Logan Ranshaw, what's the third point?
-1, and then 1 over b.
Correct. -1, 1 over b, where 1 over b is simply the reciprocal of the base. 0, 1, which would function as the y-intercept. And 1 comma b. So just like we did with square roots and cube root graphs, and you probably did maybe in the first trimester with quadratic graphs, your h and your k's, they still stay the same. It's just now we're going to do them off exponentials, and we're going to use these 3 points as our base points, if you will. Example 2. How does the graph of each function compare to the graph of the parent function? In our first graph will be y equals 4 to the x plus 2 power. So the first thing you have to realize is you have to realize this is an exponential graph. How do you know it's exponential? Because the exponent is a variable. So as soon as you recognize, hey, it's exponential because the exponent's a variable, you should immediately think to yourself, okay, that means that I'm going to be looking at the points -1. And what would the point for -1 be here? 1 over b. And what's our b? What's our base of our exponent, guys?
4.
Very good. 0. Thank you. And 1. Perfect. However, our points will be transformed. What are we going to do? What is our transformation going to be in this case? It will be x or y. Answer me that. It will be x. It will be not up to, because x's don't go up and down. It will be left 2. Remember, anytime you do a transformation, whatever happens to x, it will go opposite in the actual transformation. So they're adding 2 in the equation, which means we're going to subtract 2. Always go backwards for x. Which means, tell me where -1 1/4 will end up at, Emily Johnson. Can you take away 2 from the x? You tell me in this point what's x. Take 2 away and you'd get? You just did the first one. Tell me about 0, 1. Tell me, Alex Smith. Where's it going to be?
-2, 1.
Correct. Tell me, Cassie Markland, about 1, 4.
Am I just subtracting
Yes.
to -1?
Yes. Done. Miss Johnson.
What is T?
Transformation.
It's the y.
Y equals 5 times 0.25 to the x power plus 5. Miss Baker?
Your y will change
Yes?
5, and then multiply it by 5, and then add 5.
Correct.
5 up.
She did have the two transformations correct. We'll take 5 times y and then plus 5. Ms. Dollar?
I'm just making sure, is that like 5 times 0.25?
No. Yes. Oh, yes, it is.
Okay, because I couldn't really see it. And I just
Does that help if I put parentheses around it instead of a dot? Okay. Did I hear where did I get something?
Yes, where did you make your transformation?
The transformations came because of this 5 being out in front of the base. That's how we got to multiply by 5. And we're adding 5 after we've done the exponent, which is how we got to plus 5. Y's look exactly as they are. Hit me with some more questions if you got them. What 3 points would the graph normally go through? I'll start you out. I'll get you the x's. Raise your hand if you can tell me normally what one of these would be. Tyra Baker. One would be at 1/4. 2 left. John Hughes, where would 0 be normally? If we were to do y equals 0.25 to the x. When x equals 0, y would normally be? Yes. How about -1? Hunter Hensley. Not quite. Hunter, let me ask you this. What's our base? What are they taking to the x power?
125.
What is that as a fraction?
1/4.
And what's its reciprocal?
4.
You got it. Yep. That's the twist of this. I made this a decay problem because I turned the base to a number less than 1, which means it's going to flip it around, and -1 is going to have the higher value.
Wait, how did you get those ones?
How do we get the y's? Okay? It goes back to this. In an exponential function, y equals b to the x, it always goes through -1 in the reciprocal of the base, 0, 1, and 1 in the base itself. And in our case, the base is 0.25. Okay?
Oh, we didn't do the transformation.
We have not done the transformations yet. No. Nope. We're just getting out the initial 3 points. Now we'll do the transformations. Ms. Cowan, you had a question before we do.
I was just going to ask what that number was. I forgot.
Okay? All right. We feeling good? No. In this case, nothing will be done to x. There's no plus or minus next to the x, so nothing will occur. Very good. All right. Who haven't we heard from today? Mr. Wessel. Transform -1/4 and tell me what the new point would be. Nope. Remember, the transformations Tyra told us we're going to do 5 times the y and then add 5 to that. So -1/4 would be not 0/4. Take the y, multiply by 5, and add 5. And the x's don't change, and you have that correct, Mr. Wessel. -125. 0, 1. Chris Weissman.
0, 10.
Correct. Now the challenge one. 1 and 1/4. Logan.
1/25.
Nope.
No.
Nope.
Alright.
Multiply by 5 and add 5.
5 and 5. Where's the 3?
I like what you're saying. What he's saying is it's 5 and 5/4. And he's right, because 5 times 1/4 is 5/4, plus 5 would be 5/4. But we normally don't write mixed numbers that way. We don't like mixed numbers and impropers mixed together. So 5/4 would be,
0.5.
okay, that is correct.
Oh, no.
Can you
Oh,
turn that
want
to a mixed number?
Okay, you want fraction. Not fraction, decimal.
No, I want a mixed number.
Mixed number?
Yeah,
I did 25 before, right?
that's the improper fraction. You're correct.
Ah,
Turn that to a mixed.
6 and 1/4.
There you go, 6 1/4. I like decimals too. If you give me 6.25, I'm not going to be upset. All right, talk to me with questions. This is a hard one. Okay? What's next? Oh my word, there's a 3. You got to change both the x and the y. Yes, I can read that. It would be -3 times 2 to the x minus 1 power plus 4. Guys, let me ask you this. If we stripped away everything except the base and the exponent, what would it say? What's the base? Tell me that. So we have to base what we're going to do off the points 2 to the x. So give me the 3 points that 2 to the x goes through. -1. It'd be 1/2.
Why aren't we including
Yes, sir?
-1?
We are. But the first thing you need to do, Josh, is get the 3 points that you're going to transform. So we just strip it down to just the base and the exponent.
Then
0, 1,
1, 2.
1, 2. Okay. Remember, -1 is always the reciprocal of the base for y, 1 is the base itself, and 0 is always 1. All right, let's get our transformations here. And I already heard someone say we have to do 2 things. What are we going to do to x's? Correct. We're going to add 1 to x. What are we going to do to y? Does it make more sense if I write it out instead of doing like I did on the last one, right? Like before I wrote x plus 1. I think that might have been confusing.
Yeah, I like the first one.
You like the other way?
Yeah.
Okay. So x plus 1 and -3y plus 4. Okay. Again, it's great that you know the transformations, but you got to know what you're going to transform. Okay? So, in our transformers, isn't that a movie? Okay. All right. I'll take a volunteer. Who out there thinks they can tell me where -1 1/2 would end up? Tyra Baker. 0 and 3.5. How'd you get to 3.5?
Half times -3, which would be -1.5, and then half of it.
I like what you're telling me. I just don't like what you gave me for the answer. Be 2.5. Okay. That's okay. Hey, that's the hardest one because you got to deal with the fractions. All right, I'll take a new volunteer. Cassie Markland says you got 0, 1 to be at 1, 1. Agreed. 1 more to go. Chris Weissman says
2, -2.
2, -2. I concur. How you feeling so far?
Did we just graph that?
That would be it. Graph those 3 points and draw a nice exponential curve through it. You guys want to do 4, or you feel like you got it and we don't know what to... Okay. Yeah, I threw 4 on you with the intention of this being a real challenge problem. So, okay. So let's do this. Strip it down to just the base and the exponent, and what would you have? Okay. Hang on. Ah. Okay. All right. So if we're going to deal with 3/4 to the x, tell me the 3 points we're going to transform. -1, no. Not 1 1/4. 1 1/3, which is 4/3. 0, 1, yeah. And 1, 3/4. Okay. Sweeney.
How do you find those?
How do we find those? Not a problem. It's always 0, 1. It's always 1 in whatever the base is. And -1 will be the reciprocal of the base. So the base is 3/4 because that's what we're raising to the power. So that's it. Every exponential will be the way. Riley, does that help?
Yeah.
Okay. Okay. Who else needs help? Travis? Okay. All right. Guys, tell me what's going to happen to these 3 particular points. We will take away 4 from all the x's, yes. We will multiply all the y's by 2 and subtract 1. Awesome. You've identified the proper transformations. Now apply those transformations and tell me what new point you're going to end up with. I hear -5. 1 2/3. I thought that was what? Hit me?
Oh, x minus 1 x plus 1.
Yep. You guys realize, let me go off topic here for a second, as I'm prone to do too much of. That's not going to go away. Resume. Oh. Dang it. No. Hold on. Can I get back to that? Wait a minute. I know what I need to do. Maybe. Hang on. Sorry, guys. I lost it all. So it was -1, 1 1/3. It was 0, 1. It was 1 4/3. You guys told me we're going to do 2 times y minus 1. We're going to do x minus 4. So it ended up at -5, 1 2/3.
And then the next one's -4. Then -3 and then 0.5. I think it's 0.5. I don't know.
1/2.
It's supposed to be 1 3/4.
Oh, 3/4. Thank you. That's why it was confusing me, because I'm thinking, how are we going to get a half out of a third? But that makes sense. So what you got, Sweeney? -3 and what?
-3 and 1/2.
I like it. All right, Riley Gardner.
How do you decide what, like,
Hey,
transactions or whatever they...
the transformations?
Yeah.
Okay.
How do you decide which ones you are going to make? I think I know the x minus 4 one
Mhm.
out of the exponent, but what's the other one?
The factor that's in front, that means we're going to multiply by the y, and anything added or subtracted is subtracted from the y. And you always have to do it, the y's you do in proper PEMDAS order, so you multiply first, then subtract. If they threw an x in here, which I doubt if we're going to do that yet, you would do it backwards order. You would do the subtract first and then multiply by the reciprocal. That's it. Great question. Okay. Just trying to read some faces. Hit me, Beth Baker.
If they were to switch the 4 and the x around, could they do like 4 minus x?
Great question. What you would have to do if they did that is whoa. Tyra's question, what happens if they did this? We would have to do like we did last week. We'd factor out the -1 to turn it into x minus 4. So then what our two transformations would be, we would take, we would do x plus 4 and then divide by -1. Which, essentially what's going to happen, this normal exponential graph would go like this. The presence of that negative in front of the x would cause it to reflect horizontally and make it go like this. Okay. No. Okay. All right. How you guys feeling? Give me some feedback here. Based on the questions you're asking me and the responses you're giving me, I feel pretty confident with you. Okay, here's the last part. Natural base exponential functions. A natural base exponential function is an exponential function whose base is the natural number e. Natural base function is an exponential function, so the variable will still be an exponent, but instead of the base being an integer, the base is the natural number e. E is the natural number, named after the Swiss mathematician Leonhard Euler. Not Einstein. Oh. Hey, math is fun. Euler's number. Number E is a famous irrational number and is one of the most important numbers in mathematics. Here's the first few digits of E. Have those memorized by Monday.
Which first few, by what do you mean, all of them?
Yeah.
Alright.
I'm kidding. You guys should know that E is approximately 2.718. Okay? As you can see, it is often called Euler's number after Leonhard Euler. Okay? It is the base of natural logarithms, which we will talk about next week. But you guys need to know today that it's this. Wrong lesson. Your calculators. You will never ever put in 2.718 to your calculators. Your calculators come programmed with E. Come equipped with E already programmed. To find E, look for a key called ln. The shift of ln is your E key. So it's already got E programmed into it. Yes, sir.
I think mine actually says E, I'm not sure.
It may say E. Is it lowercase or capital E? Lowercase E means E.
Right
Yes.
there. It's like really tiny purple.
That is your E.
Okay. You gotta press alpha and that number and it gives you that thing.
Yes. What you can also do, look over here at your ln key. 3 up from the alt. There's your E. So if you just do shift and this, it's ready to do E to a power.
Okay.
Okay. Yours is going to be under the ln. Yep. So you're going to go second ln. Are you ready to do it? Okay. Find yours. Okay.
C and E, but I have like that next to it.
Yes, that means e to a power.
Is that what I use?
Yes.
So L is E.
Ooh, what the heck do we do there?
I think press the second button.
Yep, it's ready to do e to powers already.
Wait.
Anybody else that needs help finding your e?
I got now.
TIs should be second ln for you.
When I press it, it comes up with 1.
Okay, that means on your calculator, Destiny, you're going to have to type in the exponent first, like type in 5, and then do second ln. Now it raised e to the 5th power. Okay? All right. We use natural-based exponential functions when we describe functions that exhibit continuous growth and decay. A lot of times these exponential functions have a lot of applications in the world of finance and banking. Because, how many people in here have a savings account? Okay. If you have a savings account, what's the purpose of you putting money in the bank? To save it and you get interest. Interest is based upon a what? Starts with a P. Percentage. Yeah. If you listen to the commercials on the radio, I think Fifth Third used to be a big sponsor of Reds games. 2.5% APR, member FDIC. Okay? It's based upon a percentage where your investment grows by a fixed percentage each time period. Exponential growth. In banking, there are certain time periods where your money is compounded. If it's semi-annually, they do it twice a year. June 30th, December 31st. They pay you interest. If it's quarterly, they do it 4 times a year. March 31st, June 30th, September 30th, December 31st. In nature, things that grow continuously don't have a clock on them. Here's my analogy. Suppose that today I decided to bring my lunch with me to school. And I packed a tuna fish sandwich on wheat bread with Dijon mustard and dill pickles. But then when I got here to school, I found out we were having breaded pork on bun. And I said, man, I'm eating breaded pork. So I went and bought lunch. And I forgot that I made a sandwich. And I stuck it in my cabinet, and I don't go into that cabinet very often, and I forget that it's there.
Oh no.
What's eventually going to start happening to my sandwich? It's going to decay. What's eventually going to start growing on my sandwich? Mold. Mold doesn't have a clock that says, wow, it's the end of March. I get to grow some more mold today. It grows continuously. Anything that grows continuously we describe with a natural-based function. Okay? Yesterday you had the formula A of t equals P times 1 plus r to the t. Today you get a new formula that I think I forgot to write in here. I did. Okay? Here's the formula, and it's going to be very simple to know when to use what formula. You only use the formula that I'm about to show you. The problem will say continuously. If it doesn't say continuously, you don't use this formula. You use the formula from yesterday. And here's the formula for continuous compounding. P e to the RT. PERT for short. My first period class today told me about Mrs. Listerin telling them about MOP. I had no idea what MOP was.
Multiply, opposite,
Plus.
Yeah.
I think it was match. They told me match opposite plus.
Oh, yeah.
Okay. So ladies and gentlemen, in this problem, and a lot of your continuous compounding problems will in fact be story problems, you have $1,500 in a bank account that pays 4.5 annual interest compounded continuously. How much will you have in the account after 15 years? Ladies and gentlemen, what number is P?
1,500.
Correct. What is R?
0.045.
Correct. Great question. What you start with is always P. The percentage is always R. And T is always going to be your time. T would be your 15. T is always the time factor. The natural base. So you're going to use your calculators and use the natural base number. E is never something you replace. No. You can do it in years. Okay? So, here's what you would do with this. I would go ahead and multiply my rate times my time. And if I remember correctly from this morning, that's 0.675. Can someone confirm my math for me? Let me get out of here. Fire away.
On the exponent, if it's like 2x, for example,
Yes?
it's not on here, would you do 2 times negative x? Or, I mean,
I think I see what you're saying.
saying.
So if you had,
I saw it on accident when I started the wrong chapter.
like this,
Like 60.
17, I see what you're saying. So what you would do,
6, 8.
half of x. Or, because they're multiplying 2 times x, so we do the inverse operation. They divide by 2.
I didn't know if it would just be like -2 times x.
No, that would be if it was x plus 2. They multiplied, so we divide. Okay? You're welcome. All right.
Well, I have everything done except
Oh,
for the review problem.
dang it, I'm out of stuff for today. I guess that means it's going to be time to give you your assignment.
Okay. Are these gonna be like from 6-8? Is that for today's? I have questions about this because I'm still confused.
Okay, we can do that. All right. Your assignment today, ladies and gentlemen, will be the following. Page 447, you will be doing numbers 16 through 21, followed by 28 through 32. I'm going to throw out 36 and 37. We'll talk about half-lives more in general. I'll put that in maybe tomorrow or early next week. We'll maybe spend a whole day on half-lives because it's kind of an interesting topic. Half-lives and carbon dating. So 16 through 21, 28 through 32, finish it up with 51 through 60. Okay.